Okay, I want you to mentally transport yourself back with me. Let's go to the year 1859.
Mm-hmm.
It's maybe a Tuesday. You're in London. The fog is thick. You've got horse-drawn carriages clattering on cobblestones.
Queen Victoria's on the throne.
Exactly. The world feels, well, it feels established, solid. And if you walked into a pub or a university and asked, hey, where did all these birds and beetles come from? You wouldn't get a debate.
No, not at all. You'd get one single unified answer.
And that was?
The intellectual landscape was really defined by a concept called special creation. The belief, and this wasn't just, a religious thing, it was the scientific consensus, was that species were fixed, immutable. A dog was a dog, a barnacle was a barnacle, and they were created exactly as they are now.
So no updates, no patches, no version 2.0. The software shipped as final.
Essentially, yes. It was a completely static view of nature. Things fit their environments because they were, well, designed to fit them. But then in November of that year, this green-covered book lands on the shelves.
And the static world just fractures.
Yeah, it does. We're talking about Charles Darwin's On the Origin of Species.
And that is what we are unpacking today. But we aren't just giving you the high school biology summary. The monkey stands up, becomes a man.
Right.
We're diving into the story behind the book, which, honestly, plays out like a Victorian thriller. You've got a 20-year secret, a guy terrified of being called a heretic.
A high-stakes race against a rival.
And a theory that just fundamentally changed what it means to be human.
It really is the ultimate paradigm shift. Before this book, humans were sort of observers of nature, standing apart from it. After this book, we were part of the family tree. But to get there, we have to understand that Darwin didn't start out as a revolutionary. He was actually studying to be a clergyman.
Which is pretty ironic, considering where he ended up. So the story really kicks off when a 20-something Darwin, who is basically drifting, talks his way onto a ship.
The HMS Beagle.
The Beagle?
Yes, the voyage of the Beagle. This is the crucible. It's 1831. Darwin is 22 years old, and he's hired essentially as a conversational companion for the captain.
Not even as the scientist.
Not officially, but he ends up serving as the ship's naturalist. And this isn't a quick cruise. This is a 5-year trip around the globe.
5 years. That is a staggering amount of time to be stuck on a wooden boat. And he was famously seasick for most of it, right?
Horribly seasick. He spent weeks at a time just incapacitated. But that isolation and the sheer length of the trip is what forced him to look at the world differently. He had time to read, to think, and crucially, time to dig.
Okay, let's talk about the digging, because one of the first things that shakes his faith in this fixed species idea isn't a bird or a turtle, it's bones.
Giant, dusty bones in Argentina. This is a key moment that often gets overlooked. In South America, at a place called Bahia Blanca, Darwin unearthed fossils of extinct megafauna.
And he found the remains of something called a glyptodon.
A glyptodon, which, for those of us who aren't paleontologists,
it's basically a Volkswagen Beetle-sized armadillo.
A giant, heavily armored tank of an animal, yes. But here's the kicker. Right there, in the same region, scampering around, were modern small armadillos.
So if species were created independently and they're fixed, why would a creator make a giant version, wipe it out, and then create a tiny version that looks almost exactly the same in the exact same spot?
That's the question. Why not replace it with a kangaroo or a bear? He called it the law of succession. Why is there this continuity in time within the same space? It suggested. A link.
That the modern one was somehow descended from the ancient one.
Exactly.
So he's got these ghosts of the past haunting him. But then he moves in space, from the mainland to the islands, and this is the part everyone thinks they know.
The Galapagos.
The Galapagos.
It's a cluster of volcanic islands off Ecuador. Now, the standard story is Darwin saw the finches, had an aha moment, and wrote the theory. It wasn't that clean.
Not at all.
He didn't even realize the finches were all finches at first. He thought they were blackbirds, wrens.
He had to get back to England for an expert to tell him, hey, Charles, these are all basically the same kind of bird.
Correct. But what he did notice on the islands were the tortoises. The vice governor told Darwin that he could tell which island a tortoise came from just by its shell.
That's a wild detail. So on one island, the tortoise has a domed shell. On the next island, which is just a few miles away, the shell is shaped like a saddle.
Right, it flares up so the tortoise can stretch its neck higher. And this baffled Darwin. The climate was identical, the rock was the same. If species were designed for their environment, why would you need a slightly different model for islands that are practically touching?
It's like finding out the squirrels in one part of a city have different tails than squirrels in another part. It just doesn't make sense unless...
Unless they changed.
Yeah.
Unless they adapted to local conditions over time. He started to realize that island species were related to the mainland species, but they had drifted.
They'd become something new. So he comes back to England in 1836. He has crates full of bones, dead birds, beetles. He's got the clues.
He has the clues, but not the answer. He knows that evolution happened, but he doesn't know how.
And that's the critical distinction, right? The idea of things changing wasn't brand new.
No, not at all. His own grandfather, Erasmus Darwin, had written about it, but nobody had a mechanism. No one could explain the force driving the change. It just seems like magic.
So Darwin does what any confused scientist would do. He starts hanging out with pigeon breeders.
It sounds absurd, but this was his genius. He realized the best place to study change was in the barnyard. He joined pigeon clubs. He drank beer with fanciers. He studied the fancy breeds.
The pouters with their puffed up chests, the tumblers.
The fantails, and these birds look wildly different. I mean, a pouter looks like it swallowed a tennis ball.
But they're all biologically the same species. They're all descended from the rock pigeon.
Exactly. And Darwin saw that humans, through artificial selection, had sculpted these birds. If you wanted a longer beak, you picked the birds with the longest beaks and bred them. Repeat that for 100 generations, you get a new-looking bird.
Okay, so humans can play God with pigeons. We can select traits. But here's the roadblock. Nature doesn't have a breeder. There's no farmer in the sky picking which wolf gets to be fluffier.
Who is doing the selecting in the wild? That is the missing piece. And it clicked into place in 1838. He was reading a book by an economist, Thomas Malthus.
So biology meets economics, a crossover nobody asked for, but it changed everything.
Malthus wasn't writing about birds. He was writing about the Victorian poor. And his argument was just a cold mathematical reality. Populations grow geometrically, they double and double again. But resources, food, space only grow arithmetically.
So inevitably you have way too many mouths and not enough bread.
Exactly. Malthus described a world of inevitable famine, war, death. It was bleak. But for Darwin, a light bulb went on. He realized this didn't just apply to humans. It applied to every single living thing on Earth.
A single oak tree drops thousands of acorns. A salmon lays thousands of eggs. If every single one survived,
the world would be buried. But they don't survive. That's the key. The vast majority die before they can reproduce. Nature's a slaughterhouse. And Darwin realized that in this intense struggle for existence, the survivors are not random.
They're the ones with a slight edge.
A slightly sharper beak, a slightly faster wing, a slightly better camouflage. The breeder in nature is death. If you have the trait that helps you survive the drought or escape the hawk, you live. You pass that trait on. If you don't, you die.
And just like that, he has it. The mechanism.
Natural selection. The environment selects the winners.
It's brutal, but it works. He had the theory by roughly 1839. So he's got the answer to the biggest question in history. He's 30 years old. He runs to the printing press, right?
Not quite. He sits on it.
For how long?
For 20 years.
20 years? That is agonizing. I can't keep a secret for 20 minutes. Why did he wait?
Fear. Pure and simple. You have to remember, he was a respectable Victorian gentleman. He was part of the establishment. He knew this theory would be seen as an attack on the church, on society, on the very order of the universe. He famously wrote that admitting to it felt like confessing a murder.
He was afraid of being branded a radical, an atheist, a social pariah.
So he just gathers more and more evidence. He studies barnacles for 8 years just to establish his credibility. He's building this fortress of facts so that when he finally does publish, no one can tear it down.
But he might have never published it at all.
He might have died without publishing it if it wasn't for the mail he received on a June morning in 1858.
Enter the wild card. Alfred Russel Wallace.
Wallace is a fascinating character. He's kind of the anti-Darwin. He wasn't wealthy. He was out in the Malay archipelago.
Modern-day Indonesia.
Right, catching beetles to sell to collectors just to make a living. And while he's there, shivering with the malaria fever, he has a vision.
He basically hallucinates the same theory Darwin had spent 2 decades refining.
He does. He realizes that death keeps population numbers down, and the fittest survive. He writes it all down in a frenzy and mails it to, guess who?
Charles Darwin. Imagine opening that letter.
Oh, he was devastated. He wrote, all my originality, whatever it may amount to, will be smashed.
So he faces this moral dilemma. Does he burn the letter? Does he let Wallace take all the credit?
This is where it could have gotten ugly, but
Ah.
they handled it, surprisingly politely. Darwin's friends intervened. They arranged for a joint presentation.
A gentlemanly compromise. We both thought of it.
Exactly. And honestly, the reaction that night was underwhelming. The few people there didn't quite grasp it, but it lit a fire under Darwin. He scrapped his massive encyclopedia and wrote a shorter abstract.
And that abstract became On the Origin of Species.
Published November 24th, 1859. And unlike the presentation, the book did not go unnoticed.
Sold out on the first day.
It was an instant sensation. It was discussed everywhere. It became the cultural conversation of the century.
Okay, so the book is out. Let's look under the hood. How did Darwin explain natural selection to a public that had never even heard of genetics?
Well, he didn't need genetics. The logic is incredibly robust. It relies on a few observable facts. First, variation.
Right. No two individuals are identical. Look at a litter of puppies.
Exactly. Second, heritability. Puppies tend to look like their parents. Traits are passed down.
Even if he didn't know about DNA, he knew tall parents usually have tall kids.
Correct. And finally, the struggle, the Malthusian pressure. So let's apply this. Let's go back to those finches.
Okay. A finch on an island. A drought hits.
The drought changes the environment. The plants with small, soft seeds die out. The only food left are these large, tough, spiky seeds.
So the buffet has changed, and now that variation matters.
It matters a lot. If you're a finch with a standard small beak, you can't crack the tough seeds. You starve, you die.
No offspring.
But if you happen to be born with a beak that was just, say, 5% deeper and stronger, a random variation, you can crack the nut.
You eat, you survive, you find a mate.
And your chicks inherit that slightly thicker beak. Now imagine this happening over 100 years of drought. The entire population shifts. The average beak size gets bigger.
And if you extrapolate that over 1,000,000 years...
You don't just get a thicker beak. You might get a bird that stops eating seeds and starts eating insects. Eventually, they're so different from their ancestors, they're a new species.
It's gradualism. It's not a lightning bolt. It's a slow, relentless grinding.
Natura non facit sultum. Nature makes no leaps. That was Darwin's motto.
Now, critics then and now say, okay, nice story, but where's the hard proof? And this is where the origin really shines. Darwin just stacks the deck with evidence.
From completely different fields.
Right.
We talked about fossils, but he also leaned heavily on embryology.
This is one of the most compelling parts.
He pointed out something anatomists knew but sort of ignored. Why do embryos of very different animals look so similar?
Yeah, a very early human embryo has a tail. It has what look like gill slits.
Why? Why would a separately created human have the blueprint for a tail and gills? Darwin argued these are heirlooms, leftovers from a common ancestor. He also pointed to rudimentary organs.
Like snakes having tiny, useless leg bones buried under their skin. Or whales with pelvic bones.
A pelvis is for walking on land. If a whale was designed from scratch to swim, why give it one?
It's like finding a floppy disk drive in a brand new laptop. It tells you about the history of the design.
Precisely. It's evidence of descent with modification. And then there's the structure of limbs, the bone structure of a human hand, a bat's wing, a whale's flipper.
It's all the same. One bone, two bones, lots of little bones, digits.
The same hardware, just stretched or squashed for different jobs. Darwin asked, why would a creator use the exact same framework for a wing and a paddle? The answer is they inherited it from a shared ancestor.
It's a unified theory. It ties everything together. The fossils, the embryos, the anatomy.
They all point to the same conclusion, and that leads to the most famous metaphor in the book, the tree of life.
Right. Before Darwin, people saw life as a ladder.
The great chain of being. Slime at the bottom, humans at the top.
But Darwin smashed the ladder.
He replaced it with a tree. We aren't above the chimpanzee. We're on a different branch connected to the same trunk. Everything is connected.
So here we are now. We've discovered DNA. We've mapped the genome. Darwin knew none of that. Does his book still hold up?
It holds up remarkably well. In fact, genetics was the ultimate vindication of Darwin. It provided the physical mechanism for inheritance he was missing. He drew the map of the continent. Modern genetics has filled in the street view.
The coastline was exactly where he said it was.
It really was. It's so rare for a scientific theory from the 1850s to still be the bedrock of its field.
It's the foundation of all modern biology.
You can't understand antibiotic resistance or viruses or even psychology without understanding the evolutionary pressures that shape them.
It really was a shift from looking at the world as a painting static finish to looking at it as a movie. A long, chaotic, beautiful movie that is still playing.
And we're just one scene in it.
Before we wrap up, there's a thought I want to leave our listeners with. We've talked a lot about gradual accumulation, how tiny changes, a slightly thicker beak, compounded over millions of years, can turn a dinosaur into a hummingbird.
It's the power of compound interest applied to biology.
Exactly. And I think that principle applies to so much more than just beaks and claws. We live in a world that's obsessed with the hack, the overnight success.
The radical transformation. We want to evolve instantly.
But nature shows us that the most powerful changes are the ones you can barely see happening day to day. So whether you're trying to learn a new language or get in shape or build a relationship, you don't need a massive mutation. You just need a tiny variation, a small improvement.
And then you need to let time do the heavy lifting.
If it works for the entire history of life on Earth.
It's probably a solid strategy for us.
Small changes, lots of time. That's the secret sauce. Stay curious.
Thanks for listening to The Deep Dive.
We'll see you next time.